Hello students, okay, we are going to study what types of quantum numbers, okay, in our class. So what is a quantum number? Quantum number addresses what? The orbital as well as the electron, okay. What addresses about what orbital and electrons I am saying means what? It's a shape, size, where it is present, its orientation, okay. So when it addresses the orbital, only three quantum numbers are taken, that is principal quantum number, azimuthal quantum number and magnetic quantum number. But when it addresses the electron, all the four quantum numbers are considered, that is principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Okay, so first let us move on to principal quantum number. Okay, so what is principal quantum number? Principal quantum number is denoted by letter N. Okay, so this principal quantum number tells about what? The energy shell. Okay, it determines the size of the electron cloud. Okay, so when I am saying about electron cloud, okay, here it means what? Where the density of the electron is more. Okay, now energy also of the electron atom can be calculated from the principal quantum number. How? By using the formula, energy in the nth orbit is equal to 2.18 into 10 to the power minus 18 upon n square. So here this n square, this n is what? The principal quantum number. Okay, now it tells about the maximum number of electrons present in the principal shell or that energy shell by using the formula what? 2n square. Okay, then this principal quantum number is also used to take out the number of subshell. Okay, that is equal to n. N means what? Principal quantum number. So suppose that if the energy shell is 1, subshell will be 1. If the energy shell is 2, the number of subshells will be 2. If energy shell is 3, number of subshells will be 3. Okay, now next. So number of orbitals, okay, also can be calculated by principal quantum number by using the formula n square. Okay, like if it is 1, so 1 square, so in the this first energy shell there will be only one orbital. Okay, when we are saying about 2, so 2 square it becomes what? 4. So in the second this energy shell it will be how much? 4 orbitals. Okay, and so on. Okay, next coming to azimuthal quantum number. Okay, azimuthal quantum number is represented by small letter l. Okay, this formula in order to calculate this azimuthal quantum number is n minus 1, where n is what? The principal quantum number or the energy shell. Okay, now here it tells about all the descriptions about what? The subshell. How it tells? It tells about this. How it tells about the description of the subshell? Okay, by taking out this formula we can take out from small this table. I can explain to you all. Okay, suppose if this L represents what? The subshell. Okay, if the value, like I had said right now, L is equal to n minus 1. Okay, if n is 1, so 1 minus 1 it becomes what? 0. Okay, so what happens here? If n is 1, L is what? 0. Okay, and then if n is 2, okay, if n is 2, 2 minus 1, that is what? 2 minus 1 is 1. You will be writing 0 and 1. Okay, so this 0, this corresponds to what? S subshell. Okay, here also what? 0 corresponds to S subshell, and this 1 corresponds to what? P subshell. Okay, like that only if you are taking 3 minus 1, okay, it becomes 2. So 3 minus 1 is what? 2. So you will be writing 0, 1 and 2. Okay, and here it will become S, this will become P and this will become D, and so here 2 is denoted by what? D. Okay, and so on. By this formula we can take out the subshell. Okay, now it also says about azimuthal quantum number, also says about the shape of these subshells. Like if it is S subshell, it is spherical in nature. Okay, what it is? It is spherical in nature. Okay, if I am saying spherical, it means round, isn't it? Okay, if it is P, it is what? Dumbbell in nature. If it is D, it is double dumbbell in nature, and so on. So it tells about what? The shape of the subshells. Now, angular momentum can also be calculated by azimuthal quantum number. That is, L is equal to in the root L bracket L plus 1, okay, into h upon 2 pi. Okay, earlier also we have studied this angular momentum in Bohr's model of atom. In that you have seen that yes, angular momentum can be calculated by the formula nh upon 2 pi. Okay, but here it is calculated by L is in the root L in the bracket L plus 1 into h upon 2 pi. Okay, now magnetic quantum number, it is represented by small letter m. Okay, and here L you can write. Okay, m, it is calculated by magnetic quantum number is calculated by 2L plus 1, or m is equal to minus L to plus L. Okay, this magnetic quantum number tells about the orientation of the electrons. Okay, and it also tells about the number of orbitals that a subshell contains. Okay, now, and one more thing it tells is that what? Magnetism generated by the what? Angular momentum, whether it is what? Paramagnetic or diamagnetic. Okay, now spin quantum number, it tells about the spin of the electron. Okay, and it is only considered for the electron, not for the orbital. Okay, so if and what happens? The electron is spinning what? Clockwise and anti-clockwise. If it is spinning in an anti-clockwise, we write it minus half. Okay, and we represent it by what? A downward arrow. Okay, and next, if we'll write what? Plus half for the clockwise direction, and it will be a upward arrow. Okay, and spin quantum number tells about the spin of the electron, how it is moving, whether in the clockwise or in the anti-clockwise direction, and this spin quantum also tells about the magnetic properties of the atom. So we have studied about the types of quantum numbers. So what this quantum number wants to convey, or what it is saying, or what is the purpose of it. Okay, so this we are going to study right now, or I am going to explain to you right now. Okay, suppose, okay, we are given the value n is equal to 3. What is this n? This is the principal energy shell, which is representing what? The principal quantum number. Okay, so now if we have got that yes, the energy shell is 3. Okay, so we must see about the subshells also. And what tells about the subshell? The azimuthal quantum number, that is L. L tells about the subshell, isn't it? So next is what? L. Okay, so how we calculate L? Formula I have given to you, that is what? N minus 1, isn't it? And so it becomes what? 2. So values, what it will be? I have said to you earlier what the values will be. 0, 1, 2. Okay, what does this 0 represent? This represents which subshell? S subshell, isn't it? Okay, and this represent which? P subshell. This represent D subshell, isn't it? First is the shell or the energy cell, principal energy cell. Then the subshells, which is represented by what? L, that is what? The azimuthal quantum number. Okay, and what does it basically say? It tells about the angular momentum of the electrons in that angular momentum, isn't it? Now, next, what is this M? We have studied the subshells. After subshells, what comes? The orbitals, and that is represented by what? M, that is the magnetic quantum number. Okay, and what was the formula I had said to you all? 2L plus 1. Okay, one more I gave to you. What? plus L to minus L. Minus L to plus L, isn't it? So now here, keeping in that, okay, let us take out the number of orbitals that is present in S, P and D. Okay, so first taking S, okay, when we are taking S, put it in the formula, what it becomes? Okay, only one orbital. Okay, like that we can go for P also. So P also you put it in the formula. It is how much? 2L, 2 into 1 plus 1, 3. Okay, so here P 3. Okay, so if we are saying 3 minus 1, 0 plus 1, like that if you go for a D, how much it will get? You will be getting what? 5. Okay, so it will become what? Minus 2. Okay, minus 2, minus 1, 0 plus 1 and minus 2. Okay, so by the orbital if I am saying, here you can see only 1. Here how many? 3. Isn't it? Here how many? 5. Okay, so now how many orbitals are there in the shell number 3? Okay, how many orbitals it will be? Formula also I gave to you. You can calculate it by n square. It becomes what? 3 square, that is 9. You calculate it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Number of electrons. Okay. One orbital can consist of 2 electrons. Okay. So number of electrons in this orbit, this principal energy shell 3. How much it will become? Formula I had given you, 2n square. Do it. 2, 3 square. That is 18. Okay. So how many electrons will be there? 18 electrons will be there in the what principal shell, that is 3. Okay, this is all about what? Principal shell, subshell and the orbital. We are going in this descending manner. Okay, principal shell, subshell, orbital. Just remember that N is the principal shell, L is the subshell and M denotes the orbital. This is all for today. Good day. Take care.